In this video, we're going to go over the third method for solving quadratic equations, which is solving by using the quadratic formula. A quadratic equation written in standard form, ax squared plus bx plus c equals 0, can be solved when using the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This formula you will need to memorize. It will not be given to you on a test or a quiz. We're going to use the quadratic formula when an equation is not factorable. The first part that I want to talk about of the quadratic formula is the radicand. Remember, the radicand is the part underneath the square root symbol. The radicand here has a special name. It's called the discriminant. Quadratic equations with real number coefficients can have real or imaginary solutions. You can determine the type and number of solutions by using the discriminant. The discriminant is b squared minus 4ac. If the value of the discriminant is equal to 0, there will be one real solution. If the value of the discriminant is greater than 0, then there will be two real solutions. And if the value of the discriminant is less than 0, then there will be no real solution, but instead two imaginary solutions. So when we have one real solution, that would mean that we would have one x-intercept. If we have two real solutions, then that means that we have two x-intercepts. And if we have two imaginary solutions, then we would have 0 x-intercepts. So down here it says, find the discriminant of each of the following equations and give the number and types of solutions. So for this first one on letter A, I have x squared minus 6x plus 10. We want to find the discriminant. Remember that the discriminant is b squared minus 4ac. All of these need to be in standard form. So ax squared plus bx plus c equals 0. Equation A is currently in standard form. In this problem, a is 1, b is negative 6, and c is 10. Remember, I'm just getting a, b, and c from the standard form of a problem. A is the coefficient of x squared, b is the coefficient of x, and c is your constant. So now that I have identified a, b, and c, I can plug into the discriminant formula, which is b squared minus 4ac. And so I'll have negative 6 squared minus 4 times 1 times 10. Negative 6 squared is 36. Negative 4 times 1 times 10 is negative 40. 36 minus 40 is negative 4. So my discriminant is negative 4. And that means that I would have two complex solutions. Remember, complex means you have a real and imaginary part. Let's try part B, or equation B. We want to do the same thing. The first thing that I notice is that this is in standard form, and so I can identify A, B, and C. Here A is 1, B is negative 6, and c is 9. So I can plug into my discriminant formula. And I'll have negative 6 squared minus 4 times 1 times 9. Negative 6 squared is 36. Negative 4 times 1 times 9 is negative 36. 36 minus 36 is 0. So our discriminant is 0, and that means that when you get 0, you would have one real solution, or one x-intercept. On equation C, again, this is in standard form, so I can identify A, B, and C. Here A is 1, B is negative 6, and C is 8. If I plug into the discriminant formula, I'll have negative 6 squared minus 4 times 1 times 8. Negative 6 squared is 36. Negative 4 times 1 times 8 is 32. 36 minus 32 is 4. So my discriminant is 4. 4 is a number greater than 0, so that would mean that I would have 2 real solutions. Let's try solving these equations using the quadratic formula. So on example 1, remember that your quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The first thing you want to check for is you want to make sure that your equation is written in standard form, and it is. Don't worry about factoring out a greatest common factor. We are not solving by factoring. We're solving by using the quadratic formula. So instead, I want to identify a, b, and c. In this problem, a is 3, b is negative 3, and c is negative 126. So I'm just going to plug that into my quadratic formula. So I'll have x equals negative b. Notice how I have two negatives here. This first negative is from the negative sign in the formula, and then b is negative 3. So this negative comes from the formula, this negative comes from b. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Make sure that your fraction bar starts with your negative b and goes all the way until the end of your square root. Make sure your square root symbol goes over the whole part of your discriminant. The x and the equal sign are not included in the fraction. It's x equals and then we have our fraction. Now that we have plugged into the quadratic formula, we're just going to take this step by step. Let's look at this very first part to begin with. Minus negative 3. Minus a negative becomes a positive. So here I am going to have positive 3. Plus or minus. And then we have the square root of our discriminant. The next thing that I want to calculate is this discriminant. And that is what I am going to type into my calculator. So I'm going to do negative 3 squared minus 4 times 3 times negative 126. And when I do that, I get 1,521 divided by 2 times 3 is 6. So I just broke this up into 3 parts. The part outside of my square root symbol, minus a negative became positive. My discriminant, which is underneath my square root symbol, when we did that, we got 1,521. And then the part in my denominator, 2 times 3 is 6. The next thing that I want to do is I want to simplify this radical. So if I find the square root of 1,521, it is a perfect square. If this was not a perfect square, then you would use the birthday cake method or perfect squares to simplify. So right now I have x equals 3 plus or minus the square root of 1,521 is 39. And this is still being divided by 6. Remember that this plus or minus symbol means that you have two things happening. You have 3 plus 39 divided by 6, and you have 3 minus 39 divided by 6. I can simplify each of these expressions. 3 plus 39 is 42. 42 divided by 6 is 7. 3 minus 39 is negative 36. Negative 36 divided by 6 is negative 6. So I got two solutions. My two solutions are x equals 7 and x equals negative 6. I knew that I was going to get two solutions here because my discriminant was a number greater than 0. And when you get a number that is greater than 0, you should have two real solutions. Because each of these solutions are real numbers and because that they are rational numbers, I could have actually factored this expression to begin with. And if you were to factor this, you would get these same answers here. Let's try another one. Again, we're using the quadratic formula to solve. That quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The first thing you always want to do is make sure your quadratic equation is written in standard form. Example 2 is not written in standard form. Remember that standard form is ax squared plus bx plus c equals 0. This equation does not equal 0. So the first thing I'm going to do is I'm going to subtract 3 on both sides. And so I'll have 6n squared minus 3n minus 3 equals 0. Now that this is in standard form, I can go ahead and solve by using the quadratic formula. In this case, a is 6, b is negative 3, and c is negative 3. We normally write x equals, but in this equation, I'm not solving for x. In this equation, I'm solving for the letter n. So instead of x equals, I'm going to write n equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm going to break this up into 3 parts. The part before my plus or minus, my discriminant underneath the square root symbol, and my denominator. For the first part, a negative times a negative is a positive, so that's going to give me positive 3. Plus or minus the square root of, and in my calculator, I am going to calculate that discriminant. So I'm going to have negative 3 squared minus 4 times 6 times negative 3. And that is going to give me 81. Whoops. And then in my denominator, 2 times 6 is 12. So right now I have 3 plus or minus. And what I want to do now is I want to evaluate the square root. The square root of 81 is 9. Divided by 12. Right now I know that I'm going to get 2 answers because my discriminant was a positive number greater than 0. And so because my discriminant is a number larger than 0, I know I will get 2 solutions. I can get those two solutions from this expression right here. I'll have 3 plus 9 divided by 12 and 3 minus 9 divided by 12. 3 plus 9 is 12. 12 divided by 12 equals 1. For the second one, I have 3 minus 9 is negative 6. Negative 6 divided by 12 is negative 1/2. So my 2 solutions are 1 and negative 1/2. Let's try example 3. On example 3, this one is in standard form, so I can go ahead and identify A, B, and C. Here, A is 5, B is 4, and C is negative 3. My variable is x, so I'll have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 4 is just negative 4 plus or minus the square root of, and now I am going to calculate my discriminant. So in my calculator, I'm going to do 4 squared minus 4 times 5 times negative 3. And when I do that, I get 76. 2 times 5 is 10. My discriminant is 76. So that is a positive number greater than 0. So that tells me that I should have 2 real solutions when I get my answer. So let's go ahead and keep simplifying. So I'm going to have negative 4 plus or minus. And what I need to do now is I need to simplify the square root of 76. 76 is not a perfect square, so I need to simplify it. I'm going to choose to simplify it using the birthday cake method. The smallest prime number that goes into 76 is 2. 2 goes into 76 38 times. The smallest prime number that goes into 38 is 2. 2 goes into 38 19 times. 19 is a prime number. I have a pair of 2's that will leave the square root symbol. 19 doesn't have a pair, so 19 will stay inside the square root symbol. And then I'll bring over my 10. Negative 4 and 2 square roots of 19, these are not like terms, so I can't combine them. But what I do notice is that I can reduce. All 3 of my outside numbers are divisible by 2, so I can divide by 2. So if I divide by 2, I'll have x equals negative 4 divided by 2 is negative 2, 2 divided by 2 is 1, and 10 divided by 2 is 5. So I have 2 solutions here. Those 2 solutions are negative 2 plus the square root of 19 over 5, and negative 2 minus the square root of 19 divided by 5. These are both my solutions. Let's try example 4. On example 4, this is written in standard form, so I can go ahead and identify A, B, and C. Here A is 4, B is 8, and C is 8. So I'm going to go ahead and plug into the quadratic formula. In this equation, my variable is B, and so I'm going to have B equals negative B plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Let's just take this one part at a time. Negative 8 just equals negative 8 plus or minus the square root of, and we are going to go ahead and calculate that discriminant. And so I will have 8 squared minus 4 times 8, and I will get negative 64. My discriminant is negative. That is a number that is less than 0. So this is telling me that I'm going to get 2 complex numbers as my solution. Divided by 2 times 4 is 8. So I have negative 8 plus or minus, and what I need to do now is I need to simplify the square root of negative 64. The square root of negative 64 can be broken up into the square root of 64 times the square root of negative 1. The square root of 64 is 8. The square root of negative 1 is I. So the square root of negative 64 simplifies to 8i. And this is being divided by 8. All 3 of these numbers can be reduced by 8, so I am going to reduce by dividing by 8. Negative 8 divided by 8 is 1. Positive 8 divided by 8 is 1i, so I could just leave that as I. 8 divided by 8 is 1, and anything divided by 1 is itself. So my answers are 1 plus or minus I. Remember that there are two solutions here, 1 plus I and 1 minus I. If it helps you to see how I simplified this, you could break it up into the real separated from the imaginary. So you would have negative 8 over 8 plus or minus 8i over 8. Negative 8 divided by 8 is 1. 8i divided by 8 is I. So that's another way to think about this. You can either think about it as reducing or by separating, like how we did here. Go ahead and pause this video and see if you can try examples 5 and 6 on your own. When you are ready, hit play and I will go over them. For example 5, this one is in standard form. Here in this problem, A is negative 5, B is 12, and C is 128. The variable that we are solving for is x. So I'm going to have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to have x equals negative 12 plus or minus the square root of. In my calculator, I will do 12 squared minus 4 times negative 5 times 128. And when I do that, I get 2,704. And that is being divided by negative 10. So the next thing I'm going to do is I'm going to calculate that square root. I'm going to check first to see if it is a perfect square. And if it isn't, then I will go ahead and do birthday cake for 2,704. 2,704 is a perfect square. When you do that in your calculator, you get 52. My discriminant was a number greater than 0, so I know I am going to get 2 real solutions when I continue to solve this. From here, negative 12 and 52 are like terms, so I can keep going. So I'll have negative 12 plus 52 divided by negative 10, and negative 12 minus 52 divided by negative 10. Negative 12 plus 52 is 40. 40 divided by negative 10 is negative 4. On this one, I'll have negative 64 divided by negative 10. I can reduce this. 2 goes into both of those. A negative divided by a negative is a positive. So here I'll have 32 over 5. These are my 2 solutions. Let's look at example 6. The first thing I notice on example 6 is that this is not in standard form. And so the first thing I need to do is subtract 6 on both sides to make it equal 0. So I will have 2p squared plus 11 equals 0. This is now in standard form. In this case, a is 2. B is 0 since I don't have a p term, and my constant c is 11. In this equation, the variable that we are solving for is p, so I'll have p equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'll have p equals, well, negative 0 is the same thing as 0, plus or minus the square root of my discriminant. I'll get negative 88. Because my discriminant is a negative number, that tells me that I'll have 2 complex solutions as my answer. And 2 times 2 is 4. Well, 0 plus or minus anything the 0 doesn't change it, so I can go ahead and drop that 0. And so I'll have p equals plus or minus. And the next thing that I want to do is I want to simplify the square root of negative 88. I can break this up into the square root of 88 times the square root of negative 1. 88 is not a perfect square, so I'm going to have to use birthday cake for that. The smallest prime number that goes into 88 is 2, goes in 44 times. The smallest prime number that goes into 44 is 2, goes in 22 times. The smallest prime number that goes into 22 is 2, it goes in 11 times. And 11 goes into itself 1 time. So I have a pair of 2's that can leave the square root symbol. 2 and 11 do not have a pair, so they're going to stay inside the square root symbol. And then don't forget the square root of negative 1 is I, and I is always written as a coefficient. And in my denominator, we still have 4. So right now, my answer is plus or minus 2i square root of 22 divided by 4. I can reduce my outside numbers. 2 and 4 both go into 2, or 2 goes into both of those numbers. So I can reduce by dividing by 2. 2 divided by 2 is 1, so that will just leave me with 1i square root of 22 over 2, because 4 divided by 2 is 2. Here I have 2 solutions. Those 2 solutions are positive I square root of 22 divided by 2 and negative I square root of 22 divided by 2.